everyone, this is Dr. V. I'll be going over how to count significant figures and also the math of sig figs. So for the rules, number 1, any non-zero digit will count. So any number between 1 and 9 will count. So let's write that down. Any number between 1 and 9 will count. Now it says zeros between non-zero digits are always significant. In other words, like a zero like this that's there, we call these sandwich zeros. And that's a good way to remember because they are sandwiched in between two significant digits, so they all count. Another example would be something like 5005. All right, that would have 4 sig figs. Why 4? These two count, and these two are sandwiched in, so that counts. And all of those count. Those are significant. Rule number 2, leading zeros are not significant. And so that means any zero in the beginning will not count. So you just cross those out. So another example of that would be something like 0.05. Right? That would be not, those zeros in the beginning would not count. And so that means I only have one significant figure. Rule number 3, zeros to the right of all non-zero digits are only significant if a decimal point is shown. So here the example is 1.00. Those two zeros count, all right, because they're after your decimal point. So that has a total of 3 significant figures. Same thing with this one, 0.00550. These zeros in the beginning don't count. That's from our previous rule. 550 has 3 sig figs. Again, that 0 at the end counts because there's it's after the decimal place. A number like 100 only has 1 sig fig. Only that one counts. Again, there's no decimal place there, so we can't count those. 550 again only has 2 sig figs. There's no decimal place. So if I had a number like this, 7.000, that would have 4 significant figures. Again, these 3 zeros count because they're after the decimal place. And lastly, number 4, if a number is written in scientific notation, the digits in the coefficient are significant. So only these right here are significant. So 2.210 times 10 to the 7, only that part of the coefficient is significant. So all of those are significant. That's 4 sig figs. That 0 counts again because it's after the decimal. Number 5, don't worry about 5. We'll work with logs next semester. Okay, so let's do some practice. So over here on the left side, 1.05.0, all right, that has 4 significant figures. Let's write that SF. So why 4 significant figures? So the 1 and the 5 count. The 0 counts because it's a sandwich 0, and this 0 counts because it's after the decimal place. All right, now on the next one, that one only has 2 significant figures. Again, any leading zeros do not count. So on here, I use rule number 2. Over here on the right side, 105, that has 3 significant figures. Again, that 0 in the middle counts because it's sandwiched in. And then the next number only has 2 significant figures. Again, those zeros at the end do not count. There's no decimal place there. That goes back to rule number 3. So if we try this one here, this number also only has 4 significant figures, and it's only these here that count. Again, these do not count. On this side, these leading zeros do not count, but this 0 here does count because it's after the decimal place, so you only have 2 sig figs. Right? And then for here, I would suggest you pause the video and try to practice on your own on these right here, the independent practice, and see how well you do. But I'm going to go over it right now. So number 1 has 3 sig figs. Again, all those numbers are significant. It's a number between 1 and 9. That's rule number 1. Number 2 has 1, 2, 3, 4, 5 sig figs. Those zeros count because they're sandwiched in. That's still rule number 1. Number 3 has 1 sig fig. Again, those leading zeros do not count. So you only have 1. 5.00 times 10 to the 3. This number is in scientific notation. You know it's in scientific notation because it tells you times 10 to the power of some number. And so when we're looking at this, I don't have to do anything to that number. All I do is look at the coefficient, and that's it. So that's 3 significant figures. Again, why 3 and not 1? It's 3 because those zeros are after the decimal place. 10 only has 1 sig fig. There is no decimal place there to make that 0 significant. And I'm going to put a little star next to that one because that's the one people miss quite a bit. 504 is 3 sig figs. Again, sandwich 0. 6.09, 3 sig figs. That 0 is after the decimal place. It's also sandwiched in. 5.00 has 3 significant figures. Again, those zeros count because they are after the decimal place. 500 has 1 significant figure. And 10 has 3 significant figures. Again, that 0 counts because it is after the decimal place. And just to keep going here with 5, 6, and 7, and 8. Number 5 has 2 significant figures. Number 6 has 4 significant figures. Again, that 0 counts because it is sandwiched in. 400 only has 1 sig fig. This million number also has 1. I'm not going to go deep into scientific notation, at least not with 2, 3, and 4. But just so you know, as an intro, scientific notation, like I said in number 4, like number 4 scientific notation, you're taking a number that's in standard form, like number 1, and changing it to scientific notation. And sometimes we want to use that because we have very large numbers or very small numbers and we don't want to write all those zeros. We don't want to write 0.0000, or maybe this number too, we don't want to write it all long. We don't want to draw all those zeros out. So usually in scientific notation, you have a number between 1 and 9 as your coefficient times 10 to the power of some number. And that exponent can be positive or negative. So right now I'm just going to focus on the positives because most of what we're working on today is positive. So when you see a number here like 64,300, that there's an imaginary decimal place here that we don't see. Okay, and then we move our decimal place over until we reach a number between 1 and 9. So if I go here, I have to keep going. Like I can't stop here. Some people tell me stop here. I can't because this number is 64. I need to keep going one more time. And so here's where I stop. So my new number is 6.43 times 10 to the power of however many times I moved. I moved over 1, 2, 3, 4 times. And so my number now is 6.43 times 10 to the 4. That makes sense. 10 to the 4 indicates that I have a big number. And that's how we work with scientific notation. Besides this, we also worked on rounding numbers. So you guys know how to round. But now we got to work on rounding to the correct number of sig figs. So on A, if I want to round A's, it's going to be 0.0456. Again, that has 3 sig figs. Those zeros in the beginning don't count because they're leading zeros. And as you see, I did 4, 5, and then this had to be rounded up because it was getting close to that 6, so I rounded up. B, if I want to round that to 3 sig figs, that would be 7.65. Letter C is same thing, 4.97, but don't forget about the exponent there, the times 10 to the 7. All right, letter D is a little more tricky. It only has 1 sig fig at the moment, but we want to make it 3. So there really is no other way unless you convert it to scientific notation. So what I do is, again, I have my imaginary decimal place here and I move it over. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8.00 times 10 to the 9 because I moved 9 times. And it's 8.00 because I wanted 3 sig figs. Again, those zeros count because they're after the decimal place. And then once more, again, I only want 3 sig figs. I could round this off to 107,000, and that is 3 sig figs, and that is fine. I could have also converted this to scientific notation. I could have said 1.07 times 10 to the, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and that could have been acceptable as well because that also has 3 sig figs. All right, so that is counting significant figures and rounding. And so hopefully now you can do some counting with that. So now because we know how to count and round, now we're going to work on the math of sig figs. All right, so there's two main rules here. So there's one rule for adding and one for multiplying and dividing. So I'm going to use two different colors here. So when we add or subtract, and I'm going to write my own here. I'm going to write this here. When you add or subtract, all right, your answer is going to be in the fewest number of decimal places. Okay, so here's addition and subtraction. All right, so in the example here, you have 1.55 that has 2 decimal places. 1.2 has 1 decimal place. And so if you write it all out and you put in your calculations in your calculator, it's 2.75. Now, the rule for adding and subtracting tells me I have to use the decimal places with the fewest number of decimal places. So 1.2 has 1 decimal place after, so my answer has to also have 1 decimal place after. So here's an example that we did in class. So it's 10.824 millimeters minus 2.51. So out of these two numbers, I noticed that this one only has 2 decimal places while this one has 3. So I know that my answer has to be in 2 decimal places after. Well, when I put it in the calculator, I got this number 8.314. So I had to round this to only show 2 decimal places after, and this was my final answer. Okay, so this is kind of neat. When you add or subtract, you don't really have to worry about the significant figures, so your brain gets a little break. All you have to worry about is knowing that it is the your answer is in the fewest number of decimal places. All right, so the next one is multiplication and division. And again, you want to really make sure that you're writing what I'm doing here because it makes it stand out more, and even try to use 2 different colors. It's a different rule here. You got to use the fewest number of sig figs. Okay, so here's multiplication and division. So if I look at these two numbers, 1.2 and 2.461, this one has 2 sig figs while this one has 4. So I know my final answer has to also be in 2 sig figs. So when we put in the calculator, we got this big number, and I had to round this off to 2 sig figs. Again, that 0 counts because it is after the decimal place. Now this example that they give us down here, 120 divided by 3.0115. 120 has 2 sig figs, and this one has 5 sig figs. So I know that my answer has to be in 2 sig figs. Well, when I put it in the calculator, I got 39.8472. But that's not good. That's 4, 5, 6 sig figs. I need 2. And so, honestly, so students told me it could be 40, right? Well, that only has 1 sig fig, so it can't be that. So the next thing they said was it could be a 40.0. Well, that can't be it as well because that has 3 sig figs. How can I make this to just 2 sig figs? So I gotta put this into. I have to make this into scientific notation. So I move it over once, so it becomes 4.0 times 10 to the 1. And so if you ever get stuck and you're like, I don't know, how can I make it the number of significant figures? Then you can use this to help you convert it to scientific notation. All right. And so here I kind of already have it worked out because what I want you to look at here is not just the answers, but how I got the answers. So for example, let me go through and do the ones that are addition and subtraction. This one's also, so I'm gonna do those first. So I'm gonna explain those first. All of those have the addition and subtraction rule, which says I need the fewest number of decimal places. So 8 plus 17.2, out of those two, 8 has no decimal places. So that means I'm going to have to convert that 25.2 into making sure that my answer has no decimal places. So that's why it becomes just a 25. On number 3, I have to add up all those numbers. Again, I'm still using the same rule, fewest number of decimal places. So this one had 2 decimal places, this had 4 decimal places, and this has 1. So I know that my final answer should have 1 decimal place. So when I calculated, I got this big number, but I knew I had to round it off to just have 1 decimal place. All right, on number 8, same thing. I have to subtract both of these numbers, but I noticed that this one here only has 1 decimal place, so I know my final answer has to be in 1 decimal place. Well, it turns out that when I put it in the calculator, I had 1.7, so it just remains the same answer. 1.7 because that's 1 decimal place. On number 10, I guess I need to confirm this with a math teacher. I did PEMDAS, so I did addition first, and then I did subtraction. Although a lot of students have said that it can go either way. I need to confirm this. Either way, it doesn't matter too much, at least for what I want you to get, the fact that you're using the fewest number of decimal places. I noticed that the 8.1 has the least number of decimal places. It has 1. So whatever your number is here, it just has to show 1 decimal place. So whatever it is, as long as it has that 1 decimal place, I'm going to take it for now. On number 15, 2.105 plus 1.7 minus 8. Again, which of those numbers has the least decimal places? That's the 8. It has none. There is no decimal place. So when I got my negative number, which is okay, it is a possibility to have negative numbers. I just round this off to make sure that I don't have any decimal places. So it remains -4. Now all the other ones, I'm going to erase here. All the other ones are multiplication and division. So like number 2, number 4, 5, 6, 7, 9, 11. And then I'll leave this towards the end. Okay. So number 2. So the multiplication and division rule says I use the fewest number of sig figs total. So number 2, got 12,250.4 and 8.97. Out of those two, 8.97 is the smallest. It only has 3 sig figs. So because I have this big number, I only want 3 sig figs. So I'm going to convert that into a scientific notation. So I'm going to move over 1, 2, 3, and it becomes 1.37 times 10 to the 3. You could have also left it as 1,370, and that would have still been okay because it's 3 sig figs. Now number 5, we have 5.5 times 9 divided by 2.34. So when you see this, out of these 3 numbers, 9 has the least number of sig figs. It only has 1. So that means this answer, 21.14, has to be converted into 1 sig fig. The only way you can really do that is to round it off to the nearest whole number, 20. Or again, if you get stuck, you just move it over once, and that becomes 2 times 10 to the 1. And really, converting it to scientific notation is always going to help you out. No matter what, if you're stuck, you can always show it through scientific notation. Number 5, 3.843 times 1.5. Out of those two numbers, 1.5 has the least number of sig figs. It only has 2, so that means my final answer, this, needs to be rounded off to 2 sig figs. So that's why I rounded this to just 5.82 sig figs. 102 times 7. Again, out of these two, 7 has the least number of sig figs. It only has 1. And so that 714 needs to be rounded off to 1 sig fig. And again, a lot of students get stuck here. So if you get stuck, remember there's an imaginary decimal we don't see here, and you can move it over twice. So this becomes 7 times 10 to the 2, or that's the same thing as saying 700. On number 7, 25 and 40, well, they both actually have 2 sig figs, so it doesn't matter which one you use because they're both the same. So I need to make 100 into 2 sig figs. Again, in order to do that, I'm going to convert it to scientific notation and move it over twice. And so it becomes 1.0 times 10 to the 2 because this shows 2 sig figs. Number 9, 109 times 10. 109 has 3 sig figs, again, because that's your sandwich, and 10 has 1 sig fig. So I'm going to use this one. So 109 needs to round it off to the nearest 100 so that I can get 1 sig fig. Again, if that confuses you, you can also change it to scientific notation, 100, or you can say 1 times 10 to the 2. It's still the same. Number 11, 12.3 times 0.070. This has 3 sig figs, and this has 2 sig figs. Again, these zeros don't count, but that 0 counts because it's after the decimal. So it means my final answer needs to be in 2 sig figs. So 0.861, I could literally just leave it as 8.6 times 10 to the negative 1, or I could just write 0.86, and that's fine. Okay, that is also 2 sig figs. Now, so I'm going to stop here and I'm going to rewrite the other problems because it's a little messy. So on number 12. So number 12, that really is not difficult. What's difficult is about putting it in the calculator, and we'll go over that later. So number 12, use a different color. 1.0 has 2 sig figs, and this has 2 sig figs as well. So it really doesn't matter which one you use because they're both 2. So that number needs to be converted into 2 sig figs, so it's 2.1. Okay, on number 13, this is what it looks like. 4.5 plus 12.8 divided by 2.75. Okay, when you have two rules here, because you have the addition rule and you have the division rule, you need to keep track of your numbers. So what I mean by that is you have to show me 4.5 plus 12.8. That's 17.3. Now that's divided by 2.75. This is very important because you need to keep track of this. The fact that, well, at least in this point, they're both 3 sig figs. So that really didn't matter for this. Doesn't matter. So whatever your answer was here, you need to change it to 3 sig figs. So that's 6.30. It really matters more on number 14. So number 14, when you look at it, it's 19.5 minus 18.7 divided by 18.7, and then all of that multiplied by 100.0. So I need to keep track of this. So 19.5 minus 18.7, all right, that is 0.8. So now this is what the new equation looks like. 18.7 times 100.0. So why does this become important? Again, because now both of these use the same rule. So we got to look at the one that has the least number of sig figs, all right? This has 1 sig fig. This has 3 sig figs. And this has 4 sig figs. So out of all of these, this one has the least. So my answer has to be in 1 sig fig. So if I go back here, that 4.287, that gets converted into just 1 sig fig. Alright, hopefully this video helped you. This is what we went over in class, or we will be going over in class, so make sure you review this because this follows us throughout the course. Okay.